So number 9, we get okay. Somebody tell me what they got, and then we're going to see why you got that. So who got something and they're confident, pretty confident about it? Matt.
I got 8 to the 12.
A to the 12. Okay. The reason you can get that is because what's going on among those 3 variables? What's going on among them? Multiplication. So if you're multiplying the same base, you see these A's, the same base, what do you do with those exponents? Add them. But I got 4 plus, I got 11. But don't forget this one's a 1. Okay, so that's how I get my 12. 11 plus 1 is 12. Okay, that's the basic one. Try out number 10. You can also apply that to multiple variables being multiplied. So you have your 2 parentheses, but what's going on what's going on in this problem? These are being multiplied, these are being multiplied, and these are being multiplied. So do you have to do it in a certain order? Anybody? You can do this or you can do that. Do you have to multiply in a certain order when everything's being multiplied? Nope, because that commutative property. So what do you get with the x? Abby, what'd you get x to the third? What'd you get with the y, Autumn? Y to the 7th, and then that's it. All right, when I want you to simplify, when I say simplify these, you want to have only one of each base, so 1x, 1y, and then you want to have no parentheses anymore. So are we simplified here? Yes. And another thing I'm going to throw in just a moment, you don't want to have negative exponents. So are we good here? Yes, and that won't come into play until next lesson. Okay, you guys seem to be good with this. Number 12 then. This one's slightly different because you have an exponent outside the parentheses. Okay, and basically what I'm doing here is I want to do my order of operations. So what's my order of operations first step? Parentheses. So I look here and can I make anything here simpler inside the parentheses? Nope. Now I can go to exponents. And that too means every exponent inside the parentheses needs to be multiplied by 2. So what do I get? 2 to the 2nd, a to the 4th, b to the 2nd. Every exponent got multiplied by 2. There's an exponent here? Yep. There's an exponent there. Yep. So can I make this any simpler though with the numbers? Yeah, I get my 4a to the 4th, b to the 2nd. That's as simple as it gets. Okay? How many of you got that one? How many of you, this is not too bad? You guys remember? Wow. Go ahead. No, I said each base is used only once, and there are no parentheses. So 4 is its own base, A is a base, B is a base, and they're only used once. So you're okay with that. Okay. Number 14. I'm going to give you some time to work that one out. 14. Order of operations, guys. Someone performing? Did you hear the clap? Oh.
No, you can change it.
Thank you very much. Yeah, it gets stuffy and I'm loud.
Yeah.
And the screen's hot. Okay, order of operations says I should deal what's in here, and what's in here, we're done. Then I use the exponents. What would I get here, Turner? What do I get right here?
You got 4x.
Good. And what's going on between this and this? Multiplication. So if you want to keep it clear, you can just put a little dot there. Okay, second expression. Nate, what do I get with the second one?
1/4 y to the 4th.
1/4 y to the 4th. Yeah, because 1/2 squared is 1/2 times 1/2. Okay, and then is that as simple as I can get? No. So what's 4 times 1/4? 1. X to the 4th, y to the 4th. That's as simple as I can get. Okay, page 504. I'm done making these easy, all right? You want some tough ones? So the other class was asking, Mr. A, do we have to show our work? You know, remember how I said you have to show work, get answer right? But Mr. A, what if you could do these in your head? Well, maybe you could do this in your head, but at least show me something to get to the answer. Number 12. Show me something. And if you're doing this on your head, it's very easy to make something up. So I need the work on that paper so that I know what's going on. And I know that you know what's going on. So if you're doing order of operations, you're looking at those parentheses, there's nothing I can do with them. Simple, simple. But then I'm going to do with the numerator. Does anyone know what I get with my numerator? Brian? Okay, a to the, excuse me? So what do you do with the 7 and the 2? You multiply them. So you get a to the 14th, b to the 4th. What do I get on the bottom? Lily, Mooney. A to the 4th, b to the -2nd. So I did -2 times -2 is +4, and then 1 times -2 is -2. Okay, is that simplified? No, because I have 2 of each base, so I don't want that. And I think what was cool is I'm seeing your understanding, even if you don't notice it, you get this more than you did when I first taught it. What do I do when I combine these two right here? What do I get? A to the 10th. How do I get 10? Okay, exponents. If you are dividing two expressions with the same base, you subtract those exponents. So I got my 10. And then what do I get with b? B to the 6? How'd you get 6? I'm thinking 2. How'd you get 6, Maggie?
4 minus -2 is the same as 4 plus.
Oh, 4 minus -2. Gotcha. All right, that's 6. Okay, this is something you need to know. This is your answer, and that's what I'm going to require you to give me. But can you write this right here with only negative exponents? Anyone know how to do that? I only want negative exponents. Okay, 2 of you know, 3 of you may know, 4 of you maybe, 5 iffy, 6 semi. Brian. Okay, I can move this into the denominator, but what does it become? A to the, and then you're going to do the same thing with that. And then what's up top? 1. These two expressions are equivalent. Okay, if you really get that, then this is what I could have done on this problem. Look at this part right here. Are you guys saying I can move that up to the numerator? Is that possible? What does it become when I move it up to the numerator? b to the positive second. What do I do with these two now? Don't I add these two exponents? Same answer. So that's your understanding of exponents and signs of those exponents. You guys seem either very tired or very confident. Can I wake you up and or help your confidence? Okay. Number 32. So put everything we talked about on this problem, and I hope you get it right. So that -1 is an exponent of the whole thing. Yep, exponent right there. All right, when you have that exponent to the negative first or whatever exponent, all the exponents inside the parentheses need to be multiplied by -1. So I get in the numerator 7 to the negative first, m to the positive first, n to the negative third. That's my numerator now. Denominator, I got n to the negative second, r to the positive first. What do you notice about all the exponents? What basically happened to them? They all got their signs flipped. Negative, positive, negative, negative, positive. So all of them got changed. Is that simplified though? Okay, let's see if we really understand how to get these simplified. I don't want 7 to the negative first, so where can I move it? Bottom, because 7 to the positive first. Great, done with that. Do I move m to the first? No, he's already positive, and there's nothing else to combine them with. What about, n to the negative third over n to the negative second? How do you want to handle it? There's a couple ways you can handle it. 2-step or 1-step? Well, no, 2-step or 2-step, just different steps. Yep. Which one? Like, what do you do? What would you do?
I did just add the n minus 3 and when you subtract the n, it's the word.
So you got n minus 3, so -3 minus -2, which is, okay, so it would be up here as n -1, but then you have to do what with it? So it just becomes n down there. Do I move r? Nope, he's already positive. Did anyone do this? Did anyone move n to the negative third down, and it became n to the positive third, and you just add those two together, and you get n to the first, which is what we got there? Anyone? 1, 2? Okay. Do we both get it right, or do we all get it right? Yeah. So here's your simplified expression. Okay, listen to my instruction on this problem. I want all the variables' exponents to be negative. All the variables' exponents to be negative. Variables' exponents. So basically, don't move that 7. Leave it alone. Variables' exponents to be negative. I found my volunteer. Jenna, what did you get? So everything is the same. These two right here are equivalent. They're the same value, same worth. They're just in different form. And you will get that in a couple years. Okay, that was that lesson. Page 509, scientific notation. 509, number 13. The diameter of an organism called the mycoplasm is 4 millionths of an inch in diameter. Oh my. Write 4 millionths as a scientific notation number. 4 millionths. Okay, is this number bigger than 1 or smaller than 1? Smaller than 1. That instantly tells me my exponent sign.
Negative.
Yes, it has to be negative. Good. 1, 2, 3, 4, 5, 6. So I got 4 times 10 to the negative 6th. Why negative again? Why is it a negative exponent? Yes? This number was smaller than 1. And why did I have to make it 4? Why can't I use 0.4 or 40? Because those are both numbers. This number has to be?
Simple.
It has to be simple. It has to be a number between 1 and 10. So, not like that. Between 1 and 10. Okay. By the way, guys, do you know what the context of that problem is? So here, I'm going to make an inch. Have you ever seen the term enlarged for texture on cereal boxes? It means they want to show it bigger so you can see all the details. You want to see all the sugar on that frosted mini wheat. Okay, this is an inch. If you divided this inch into 1 million pieces, 4 of them would be the diameter of that mycoplasm, that the other part. So 4 millionths. So isn't that pretty small? It's pretty small. Okay, do you want to describe it as 4 millionths or 4 times 10 to the negative 6? Maybe you're like, I don't know, this is not that bad. Hey guys, I can deal with this a lot easier than I can that. Okay? You're like, how? Number 14. Number 14. Oh, man. You're multiplying scientific notation numbers? How's that? 4 millionths. You guys getting that? 4 millionths? Okay. That is just amazing. All right, on these problems, those 4 numbers, so like the decimal numbers and the powers of 10, they're all being multiplied. So do I have to multiply them in a certain order? No, I'm going to multiply these two together. When you're multiplying decimals, do you have to line up the decimals? No, only when you're adding or subtracting decimals. And you know what? I don't even want to use the decimals right now. And then at the end, I can look, 3 spaces right there. 21.708 times 10 to the, what's 10 to the third times 10 to the fourth? 10 to the 7th. Is that my answer?
Yeah, no, it's not.
What? Sorry?
You have to get it to simpler.
What does this number have to be in between? 1 and 10. Is 21.708 between 1 and 10? Nope. So I got to move it one more time. So it becomes 2.1708. But what happened to that exponent? Look at this number right here. 21.708. Is that a big number or a small number? Just this little number right here. It's big. So if I move the decimal once, do I add 1 or subtract 1? Add 1, because I went up. Because that was a bigger number than 1. Does that make sense? So I'm going to get 2 answers on this. 6 times 10 to the 6th or 10 to the 8th, and only one of them is correct. In fact, one is 100 times bigger than the other. Is that a difference? Yes, it is. Okay. And then do number 16 with division, and thankfully won't be too bad of a division problem. interpret my work on the, I'm only dividing the numbers right now, not the powers of 10, because you could do that by subtracting. You guys interpret what I'm doing up there? Look at it step by step. Don't look at it all. Okay, you see the original? What do I do? The decimal moved once to the right. And are you allowed to do that to both numbers? Mm-hmm. What in the world? I don't like dividing, so I subtract. What's 81 also known as? 3 to the 4th. What's 3 times 3 times 3 times 3? 81. What's 27 also known as? 3 to the 3rd. So what do I do with these exponents? Subtract them. What do I get? 3 to the 1st. What'd you get? 3? Oh, we got the same thing. That's amazing. And then times 10 to the, what's your 2 minus negative 3 is 5. So listen, guys, this is what I want you to get. Can you convert? Is it possible for you to convert and get this? I mean, is that possible for you guys to do? And why did I do that? Because if I have the same base, what do I do with those exponents? Anybody? Okay, guys. I'm trying to do that. You have 10 seconds to do it. Okay, fine, 15. Starting 10 seconds. Multiply those. This is for fun. Ready? You're done. Right? Are you done? Okay. That was bonus. Let's go to the next lesson. Polynomials. Page 517. We're going to be able to identify polynomials and get the degree. So you need to understand those because that helps you with later on lessons. All right. Number 14. And we could do this out loud, and you could do it on your paper if you want to write it down. Number 14, is that a polynomial? Is number 14 a polynomial? The answer is yes or no. 14, is that a polynomial?
No.
It's either this or that. How many of you say it's a polynomial? How many of you say it's not a polynomial? How many of you haven't decided yet? How many of you are waiting for your friend to tell you? How many are waiting for me to give you the answer? How many of you wish you could look at the back of the book? Okay. I need a confident answer. Matt, you gave me the answer. What is it? Is it a polynomial? It is a polynomial. Why were some of you maybe thinking it might not be a polynomial? Because it's legitimate what you guys are thinking. It doesn't look like one. It's a fraction. But it could be a fraction as long as what? Matt?
The variable isn't in the denominator.
Yeah, is the variable in the denominator? No. It's a polynomial. What kind of polynomial? Your choices are monomial, binomial, trinomial. Which one? Monomial. There's no plus or minus sign. There's only one thing there. Okay, number 15. Polynomial or not? 15. Is that a polynomial? Yes or no? And then what type? Monomial, binomial, trinomial. Okay, Jenna, is it a polynomial?
Yes.
But they have fractions in there.
But the variable's not in the denominator.
Good. Variable's not in the denominator. Fine. What kind of polynomial? Trinomial. Wait, there are 3 things in there? Yeah, 3 terms. So it's a trinomial. 16. Let's go with Carson. 16. Yay or nay? I thought we're good with fractions. Okay, so is it a monomial, binomial, or trinomial? None of the above. If it's not a polynomial, it can't be one of those. Okay. Oh, number 19, go. Alex, is that a polynomial? Decimal. You see all those decimals? Want to answer that again? Is it a polynomial? Give you another chance. Go ahead. Look at it. It's decimals. Ugh. Final guess. Go ahead. Even with decimals?
I think so.
Did I make you doubt a little bit? Okay. Success. It is a polynomial. If I'm okay with fractions, can I be okay with decimals? Does anyone know why I'm okay with fractions and decimals? They're the same thing. They're parts of a whole. So, sorry, Alex, but you did a good job sticking with your answer. That reminds me, the other class. Oh, how many of you are driving? Permit driving? Okay. Oh, perfect. So, you guys understand I used to be an instructor in the summer. In the summers back in Colorado. So, I would take Alex, and she would be driving, and I'm there. My heart's beating a little faster than normal. I have a brake, and my foot's ready to push it. And my hand is ready to grab that wheel, just in case. And I'm looking all around, like all around. Da-da-da-da-da-da. I feel like I'm just like constantly moving my eyes. But anyway, Alex is now ready for the highway. So what I would do is we would get into the highway and come right out. Because she's never driven on the highway, and I want to live. So we just want to come in, and we want to come out. And we come out, and we're sitting there at the light. And I'm asking Alex, all right, Alex, look at that road over there. I said, can you go in that road? No. Like, are you sure about that? And that light's long, by the way, so we can talk a long time. No, I don't think so. Why not? Because I see cars coming the other way. I see cars coming the other way all the time. And then I start making it, look at what you see. Look at what you see. That's kind of wait, what? Look at what you see. Go look. Okay, so there's a red sign. Are red signs important on the road? They're telling you if you don't pay attention to this sign, something bad can happen. What signs are red? Stop sign, wrong way, do not enter. Do you really want to go on those roads when it says do not enter or wrong way? So she sees how many do you see? Oh, I see 2 of them. Okay, cool. And then there's a white and black sign. Do you guys know what white and black signs are? They're the law. The law. Like what signs are white and black? Normal ones. Speed limit, so it's law. Another one, I heard it. One way. How many one-way signs are there? I see 2. Yeah, there's actually 3. But yeah, 2 of them. Okay, look at the road. Look at the painting, the lines on the road. Do you know what you see? There are no yellow lines. Right. Do you know what yellow lines tell me? 2 ways. So if there are no yellow lines, is there 2-way traffic going on there? There shouldn't be, right? So we look at it, and by the time I remember that intersection because I took students a lot there. We see 7 different ways to tell me don't go there. So should you go there? Should you go there? Are you sure about that? Okay, so she gets that confidence, and I try to make them doubt, but I saw someone go in there once. Yeah, I have seen people go in one ways all the time, the opposite way, all the time. It's scary. No. Okay, so we have evidence here. What I do with these questions, just like I did with driving instructing, is I want to make you doubt until the point where you're so certain. No matter how I say it, are you sure about that? You're going to know the answer, right? Sure. Yep. So don't be fooled by the 7 signs saying don't go that way. You know, that's kind of like the thing. If you see the signs, you'll know what to do. But it was funny because I did that a lot of doubting. But then after a while, they're like, then I go to another intersection. Can you go through that road? They're like, no. Why not? I see a one-way sign. Okay, you're done. Fine. Right? So if you're paying attention, will you figure out these things pretty quickly? But it's hard because I know distractions and all that. New places. I take them downtown Denver. That was one of my favorite drives. And they've never been downtown. So I'm like, all right, you ready for it? No. Okay, we'll get there. And we get there. Hey, we're in downtown. Did you know that? I didn't even know we were here. Yeah, because you're building up to that. I'm not throwing you in downtown unless I know you're ready. Because I don't want to get hurt. And I want to make it to home by the end of the day. So I'm looking for the same signs. Can you turn right on this intersection? I think you can. Really? What does that sign say? It's white and black. It's the wrong way. Oops. So what sign should you pay attention to? White and black. Red. Anyone? Not all of them.
Yellow.
Not all. Yellow. Because if you look at the green signs are telling you there's a beautiful park coming up. Do you really need to pay attention to the park sign? If you're looking for a park. But like if you're just driving downtown, I don't care about the park. Green lights, yes, signs I'm talking about. Signs. Yeah, lights, please pay attention. Especially those lights, when emergency signals, they're just spinning around, it's flashing lights. I wonder if I should pay attention to that. Yes, you pay attention to that. Yep.
Is Denver better than Atlanta?
Like traffic-wise?
No, just like city-wise.
I like it. It's not huge, so it's not like crowded, and the traffic's not terrible. Like, it's bad, but it's not Atlanta traffic, which is terrible. And the weather's nice.
Yeah.
Except the Broncos play there.
Yeah.
And the Nuggets. Okay, what were we doing? Okay, go to, so you're on page 517. Now I want you to tell me the degree of a polynomial. So number 21. What is that degree of that? What is the degree of that polynomial? So it is a polynomial. It is a monomial, but what's its degree? Close. So what's the degree of number 21, Abby? It's actually 5. And the way you do that is you take the exponents of all the variables and add those together. That's okay. That's what I was expecting. And Abby will be ready for the next one, right? I'm going to make you doubt. Can I try? Okay. Not yet. Give me some time. Abby? Yeah, Abby.
Jenna, you never knew her name.
Oh, wow. Okay, let's keep going here. No, I think she thought I was talking to someone else. Maybe Alex or something. Okay.
I thought you were talking to Alex about her sister, and I was like...
That's okay, yeah. That happens. 23. This is for you, Abby. 23. So this is a binomial. You look at each monomial, and then you tell me what's the degree of that whole polynomial. Okay, go ahead, Abby. I'm sorry. It's actually 3. Now, can you tell me what...
I was going to say...
Yeah. What's different between that one and the one before it?
That one has addition and it's a binomial.
Yes, so one was a monomial, one was a binomial. So look at each monomial and each polynomial. All right. Now it's time for Rosalind. Number 25. And if Rosalind, if you need help, I can phone a friend. Excuse me? 9? For number 25? I see 8 there. Excuse me? The second, so I'm looking at 18, A to the 5th, F to the 3rd. That's 8. Are you sure about that? Okay, Rosalind, you got to be really sure about it. You're sure? Okay, it's 9. Thank you. I forgot how to count. Okay, you look at each term and look for the degree of each term, then the highest one goes. All right, Lily, number 28. What's the degree of that polynomial? 28. G. Guerrero. 28. How'd you get 7?
Well, on each individual one, I added up the exponents.
What'd you get for the first one?
I got 6.
Okay.
And
Second one?
The second one, I got 7.
Okay, so I got 6 on that first one. And then what'd you get on that second one?
7.
So I think you're really, really close. Can I give you like 10 more seconds? Just look at it again. Go ahead. 5, 4. Good, because that's what I had.
Okay.
Yeah. Oh, did you say 7 already? Oh, okay. Sorry. All right. Now you're going to have to. Good job. On 32, I want you to write it in ascending order. It says descending. I need you to write it ascending. Ascending order of the variable x. Of the variable x. Not of a. X. Ascending order. Number 32. Last one. Yeah, I'm telling you a little bit different from what they're telling you. I want of the powers of x, ascending order. Okay, Lucy, can you read me that problem? Just read the problem real quick. 32.
7a to the third x plus 9a x squared minus 14x to the seventh plus 12 over 19x.
That's correct. All right, guys, we'll finish up this afternoon. Sorry to make you doubt, guys.
I know what we have to do.
Goodbye.